Welcome to the deep dive. Today, we're going deep, really deep, into a fascinating mathematical puzzle box, and at the center of it all, something called series-reduced trees.
And what's really cool is that
You, our intrepid listener, you sent over
the sequence,
some intriguing excerpts from the online Encyclopedia of Integer Sequences, specifically entry A00014.
it's like a secret code. This A0000014, it unlocks a whole world, of connections to different areas of mathematics. It's like a mathematical passport.
Okay, hold on. I'm intrigued, but
It can take us to some surprising destinations.
let's rewind a bit. The excerpts, it mentions these series-reduced trees. Can you paint a picture for us? What exactly are we dealing with here?
Okay, so imagine a tree,
Okay.
but not the leafy green kind,
Yeah.
This tree is all about points and lines, and mathematicians, they call these points vertices. Think of it like a family tree,
Okay.
where each little dot, each vertex is a family member, and the lines, well, they show who's related to who.
Got it. Okay, so how does this series-reduced thing, how does that come into play?
All right, so in a series-reduced tree, every single vertex, or like we said, family member, they can either be a leaf, meaning no branches, no children, or they have to have at least two branches, so at least two children. No single middle child branches allowed. Mathematicians like to keep things tidy.
Interesting. So it's like mathematicians looked at a regular tree and said, too messy. Let's impose some rules, make it more elegant.
Exactly. Mathematicians, we love finding patterns, order, and all the complexity. And these series-reduced trees with this no single middle child rule, well, they create, a beautifully structured system.
Okay, I'm starting to see the appeal here, but how does this tie back to our mysterious sequence 00000? What's the connection?
This sequence, it's like a head count. It represents the number of unique series-reduced trees you can create as you add more vertices, more family members to your tree. For example, the sequence, it has the number 2 in it twice.
Right.
That means that there are count them, two distinct series-reduced trees that you can make with either 6 or 7 vertices.
Wait, so for some numbers of vertices, there's only one possible way to make a series-reduced tree. That's wild. I never would have guessed that just by looking at the sequence.
Remarkable, isn't it? And what's even more fascinating is this sequence, this string of numbers, it pops up in some really unexpected places.
Okay, you've got to elaborate on that. What else is connected to these series-reduced trees?
Well, you remember that Goodwill Hunting problem?
Yeah.
The one with the math puzzle.
Oh, right. With Matt Damon.
Yeah, the one that wows everyone.
It did feel like, I don't know, a very math people thing, honestly. All those lines and scribbles.
Yeah.
Does that connect back to our trees?
Yeah, it does. Yeah, that problem, it involves finding all the different ways to draw a specific type of diagram, and it turns out those diagrams directly related to series-reduced trees.
Get out. No way.
It's this crazy connection between, the world of movies and this, abstract mathematical world.
So by counting these series-reduced trees, we're essentially solving that movie puzzle?
Yeah.
That's incredible. Math really is like this web of interconnected ideas.
You got it. And the connections, they don't stop there. Our excerpt, it mentioned this thing called graph theory.
Right.
So imagine you're mapping out relationships.
Okay.
Like friendships in a class or maybe connections in a computer network.
Okay.
That's what graph theory is all about. It's understanding these connections.
Okay, I'm seeing the link here. The lines and points of our trees, those could represent the connections in those networks.
Exactly.
But how do, the series-reduced trees, how do they specifically play a role?
So series-reduced trees, they can really simplify those networks, make them easier to analyze. They're like streamlined blueprints.
Okay.
They highlight those essential connections without all the unnecessary details. They help you see the forest for the trees, so to speak.
Oh, I like that. That's a great way to put it.
Right.
This is blowing my mind, I gotta say. I remember in the excerpt that there's a formula to calculate this sequence too, right?
Absolutely. And get this, it's on page 62 of a book by Harari and Palmer.
Okay.
Talk about a treasure map to mathematical gold.
A formula that predicts the number of these special trees. That sounds incredibly powerful. I have to admit, though, I'm more of a show me the picture kind of learner. Do we have any visuals of these series-reduced trees?
You are in luck. The excerpt, it mentions a resource by Beattie, McKay, and he actually lists out, get this, all the unique series-reduced trees with up to 22 nodes. It's like a family portrait album. of all the possible tree structures.
Wow. Okay, that's amazing. I bet seeing those different tree structures would really, I don't know, help wrap my head around this concept. This whole thing feels like we're, I don't know, peeling back layers of an onion, you know? Like uncovering deeper and deeper connections with every layer.
Precisely. This is what makes mathematics so captivating. You know, it's
Yeah.
not just about the numbers, the formulas. It's about the elegant connections that weave together these seemingly like totally different ideas.
Yeah.
And the best part, there's always more to explore.
Speaking of exploring, the excerpt also mentions something about like an error in the original formula. That's a bit unsettling, isn't it? Even in the precise world of mathematics.
You're right. It does happen.
Yeah.
Even brilliant minds, you know,
Yeah.
they make mistakes. The initial formula, it had a small omission. Thankfully, it was caught and corrected by another mathematician, Wolf Dieter Lange.
Mm-hmm.
But it just goes to show, you know, the collaborative nature of mathematics. It's a field where, you know, researchers build on each other's work, refining and expanding our understanding. It's like a giant puzzle
Yeah.
that we're all working on together.
So, okay, let me get this straight. We've got this amazing sequence, A00014.
Right.
It's connected to these like elegantly structured trees, these series reduced trees.
Yeah.
It's popping up in movie puzzles.
Right.
And even helping us like understand complex networks.
Yeah, and all of that.
It's a lot to take in.
It is, and we've really only just scratched the surface here. Remember, we've been looking at this small excerpt from the online encyclopedia of integer sequences. That full entry on A00014, it's a rabbit hole of its own, really.
Right.
Packed with even more formulas, connections to other sequences. It's
Yeah.
really fascinating stuff.
It really is incredible how something that seems, I don't know, so simple,
Yeah.
you know, at first glance, like counting trees with this no single middle child rule can lead to like this whole world, this rich and interconnected world of mathematical ideas.
It really speaks to the beauty of mathematics, you know,
Yeah.
this universe of hidden connections. You never know what you'll find. Exploring even the simplest concept, it can unlock these amazing insights.
Well, this deep dive has definitely opened my eyes to the magic, really, of series-reduced trees and really the power of mathematical exploration in general. Any parting words of wisdom for our listeners before we sign off?
You know, if there's one thing I could leave you with, it's this. Never lose that curiosity. Don't be afraid to delve into the unknown, to follow those threads of knowledge wherever they may lead. Who knows? You might stumble upon something incredible.
I think I'll love that. A huge thank you to our expert for guiding us through this fascinating world of series-reduced trees and all their hidden connections.
It's been my pleasure.
And to you, our listener, for sending us down this rabbit hole of mathematical discovery. Until next time, keep those aha moments coming.